our cam lobes and our lost motion assemblies. You'll see on bank one head, there are more lost motion assemblies because of the variable cylinder management system. I got a 12.10 here. I think that's what it is. Let's check it and see. Oh, they're hand tight.
What's going on, everybody? Mike here, AHC Garage. Welcome back to the channel. Today we got a video that you guys been asking for. We got a knocking direct injection J35 engine, and John and I are going to be taking this motor completely apart. And before we get started, a lot of you guys been asking about the tools that we use. So we pick up a bunch of tools from this company called Temu, and John's going to tell you guys a little bit more about them.
So it's a new-ish app such as Amazon. It's a bunch of stuff. So the price point and quality on them is probably not something that you would want to use every single day in a professional matter in a shop, but for your weekend warriors and DIYs, these are good things that can save you money, and you don't want to buy stuff from Fluke, Matco, Snap-on, stuff along those lines. So these are things, and a couple of these I actually use pretty regularly, and the fact that I didn't want to spend what the tool truck charges on it, and this works just fine. So we have a few things picked out here, and everything is pretty decently priced. So we can start off with this right here. So this right here is basically a power probe, and just like the power probe that you would see, the yellow ones, this one's made by Autel, and this will do circuit diagnosis. You can power up circuits with it, you can test circuits with it. It has the entire display screen on it. Once you plug it in, everything will start to work. This is the probe. It also comes with your attachments for a battery contact, an extension cable so you can get around the car, and you can also power it through the cigarette lighter outlet. Comes in a nice hard case. And how much is this thing, Mike?
$100.98.
Well, I must say that's a pretty good price, because I know the power probe product itself, a few of us in the shop have it, and we do use it pretty regular, and it's probably double or triple the price. That's a good one, especially when you're doing diagnostics of circuits, relays, and fog lights, all kinds of stuff like that. Next thing we have is this pretty cool work light. I don't have this one. I have the one that's larger than this, but this thing's pretty cool. I know it's got two different modes here and a flashlight at the front, and it's pretty compact. You could carry this thing in your pocket, and this thing, I wonder how much that costs. And it's USB rechargeable too.
$3.98.
$3.98. Okay. The next thing we have, and you know, honestly, when we went to the Tail of Dragon, I think like 3 or 4 guys got this same exact one to bring with us. It's a tire inflator, and the cool thing about it is that you can power it up, and then you can preset the pressure you want it to go to. And once it gets that pressure, it'll automatically stop pumping. It's USB rechargeable or chargeable through your outlet. And then also this USB port acts as a power pack. And it's got a little light on it too. All of this is removable. And you can also use this to inflate basketballs and inflatable stuff. It has a bunch of different attachments with it. And how much is that guy?
$40.98.
Another great product at a cheap price. That's something you could take and put in your spare tire well, and just know that you can put air in your tires when you need it. Moving on from that, we have this thing's pretty cool. You see a lot of these. I just want to stress one thing about products like this. Stuff that works off of your USB port, adding multiple ports to it, will tend to draw more voltage, or amperage, I should say. So sometimes you got to be careful and not plug like 5 things into it. This one's pretty cool because it has different charging ports at different amperage supplies. And at the bottom here, it has a voltage readout. So even if you're only running nothing through it, it'll tell you what the alternator is charging at. How much is this guy?
$4.48.
$4.48. Wow, that's pretty good. I like that. I had something like this in my D8 and tell me if my alternator was dying on me or not. That's pretty cool. Now, The one thing here I think is really cool, I really like this. This is a endoscope or a borescope. Basically, it's a camera on the end of this. So what you can do with this guy here, how you turn it on? Help me out, Mike. All right. So, look at this thing, pretty cool. It has a LED on the end of it that allows you to see what's going on. Look. Oh man, that's kind of scary looking guy there. But the cool thing about this is you can use this to inspect inside things such as your oil bolt hole in your nose. Oh, no one wants to see that. And you could see down into your spark plug tube to see if you have some carbon buildup or any damage inside your cylinder walls down in through your intake. You could check your intake valves with it. This is a pretty cool tool. This is something that I would have in the shop because a product like this would definitely cost a lot more. I think the Snap-on one is something like $1,200. I know one of the guys in the shop bought one, our shop foreman, and he's probably used it 3 times. So how much is this guy?
$45.48.
$45.48. Yeah, that's very good. And the other cool thing about this is that it has a little space here for a SD card, and that'll allow you to take photos and record video on here if you need to show someone or review it at a later time, or if you're making a video yourself and you want to use this to add a clip into your YouTube video. I'm sure we can find a way to do that. And I think we will be using this on that J35 motor to take a peek inside before we open it up and show you what it looks like on the inside. So these are all pretty cool tools and at a very, very reasonably cheap price to where for the weekend warriors and DIYers, like I said, this is perfect. We have one more thing. I almost forgot. This one's actually my favorite tool because I use one of these pretty consistently. I did buy mine from one of the tool guys on the truck, and it is almost exactly the same thing. So what this is, and it's pretty interesting if you take a look at it, this end is completely, you can rotate it, and the idea behind this is maybe I can go, we go right here real quick and I can show you on the CRX. This is for grabbing a hose clamp like that, and then it's ratcheting here so that when you hold it down, it holds the clamp for you and you can take the hose off. Very good at hard to get to places where you can't really fit a plier in there, and the design of this is non-slip. These are adjustable ratcheting hose clamp pliers. These things are awesome. And how much do these bad boys cost?
$13.78. I bet you pay a lot more for yours.
Yeah, I paid a lot more than that for this. I think I paid $85 for mine, and this does the same thing. So I feel like an idiot. But nevertheless, these are very cool tools. And this thing, even at the cheaper quality of this one at such a limited price, a reduced price, this would be something I would recommend for anyone in a shop to use because you really don't take hose clamps off 30 times a day to where you need something that's super, super solid. And like I said, this thing's adjustable. You can put it into any shape and get it out. So with all of these tools together, I mean, do you know what the total cost is for all this stuff?
Less than $210.
Less than $210. You can diagnose circuits, see what you're doing, fill your tires up, check your voltage again, and then use this scope to, look into weird places that you can't really see with your regular eye, and then take hose clamps off. I think that's a pretty good deal, and we'll put some of these things to use on this little teardown. And the only reason we're bringing this up is some people feel that if you're going to buy tools, you only buy Snap-on, but there's some things you don't have to buy, and you don't have to break the bank on it, and you can still get things done. And some of these cheaper market products, they're okay to use for some things. Sometimes they're not so good, but at the price you pay for them, if they break, you don't feel bad. So these are things that we recommend and we're going to use here. So you guys should probably check them out. You guys saw all the cool tools that we had there. There will be a link in the description below to purchase any of those or check them out if you guys want to check them out. So here is the J35 engine out of I want to say this is a 2015, 2016 MDX engine. And the customer had brought it in complaining of a knocking from the bottom end. here's the motor. We didn't even break it down. Apparently whoever took it out of the car didn't even drain the coolant or oil out of it, so we're doing some of that now. And what we're gonna do is break this thing down top to bottom, identify where the failure is, show it to you, and hopefully you learn something about the J series motor in the process. Okay, so we're gonna start from the top down on this. So first thing we're gonna do is get the intake manifold off. We're gonna get our valve covers off and just start peeling things off as fast as we can, and I'll show you what everything is as we go. So what I just removed was the part of the PCV system, and it doesn't even fill in this area here. This is pretty much not vented to anything, but it does pipe into here, and this is where it distributes the crankcase pressure back into the intake manifold. So now that we have the upper intake plenum off and the lower intake plenum off, you can see more of the direct injection system. Underneath here is our high pressure mechanical fuel pump. It's run off of a cam. We'll show you that a little bit more closely. Then under here is the fuel rail system with our fuel rail pressure sensor and all of the corresponding hardware. Direct injection systems run a lot of insulators because the injectors are noisy, as well as the fuel pump. And as you see, this was over it. It is a foam insulator to try and isolate some of the noise that comes from this. So those are some of the things that they do. They try and encapsulate this whole area. There's also usually a little protector on this side to keep all the sound inside the engine. So let's keep pulling more off. All right, so here's our mechanical fuel pump, and this is common to most direct injection engines. It's a lot like, I would say, a diesel with a common rail fuel injector system. You have a mechanical pump. It's driven off of a lobe on the cam, but you can't have this ride directly on the cam, so they use this. It's keyed into place, and it runs a roller that rides on this odd-shaped little cam part here, and it's extended straight off of the cam, and this is to prevent wear and tear on that cam pump drive gear, I guess that's what it's called. But it sits nice inside there, pumps up and down, and this is just a mechanical pump. That's a direct injection injector. The whole idea behind a direct injection, as opposed to standard port injection is going to inject the fuel up here into the intake port before the combustion chamber on the back side of the valves. What this does is it shoots fuel directly into the cylinder. As you can see, the carbon buildup on the end of these. This is why, you know, running a good quality fuel is important, and occasionally getting some kind of fuel injector cleaner in your system, because as you can see, carbon has now built up on the tip of this, and that's going to affect your spray pattern and how the fuel gets into the engine. This can lead to fuel economy issues, as long as check engine lights as well. There you go. Now it's time to pull the valve covers off. We're going to start by pulling the ignition coils first. Now that the valve covers are off, you can see a look underneath here at the cam rocker assembly. Up here is also the VTEC engages through this area here. The solenoid is no longer down here. This is just an oil pressure sensor. These are now your VTEC assemblies. And over here, you can see the head is much more complicated on bank 1 than on bank 2. So what you see here is a cylinder activation system. What this can do is shut off any one of these 3 cylinders in order to save fuel economy. And it's all done through a set of pressure switches and solenoids up here. This is VTEC along with cylinder deactivation. It all works through the solenoids in here, pistons, valves, all throughout this whole system, and they can just shut off a cylinder completely, so it's not even running mechanically anymore. Now what we're going to do is we're going to bust out one of those tools that we showed you earlier and see if we can't get some peaks down inside the engine a little bit closer before we pull it apart. All right, so this thing's pretty cool, especially since it has its light on it. And what we're going to do is we're going to clip a video here. Let's see. Now we're recording. We can come in here and take a peek down at what's going on. You can see a whole bunch of different stuff on here, such as the valve guides and the valve itself. You can see, I don't know how far down we can get on the injector port. Oh yeah, we can't get too far. That's about it.
Talking about the carbon, look at all that.
Yeah, a ton of carbon buildup on there. Then you can also see we can go straight down into the spark plug tube hole and see down inside the cylinder. That's pretty neat. If we spin it around, it gives us a little bit different angle on it. Get all the way in and even see the cross hatching on the cylinder wall. It's a pretty cool tool. Definitely like cheating a little bit when you get to see inside without taking it apart. So now let's pull it apart and see what everything looks like on the inside out. I don't know, we'll take it apart. So we're gonna pull off the coolant crossover pipe here. What this does is it has a pipe that leads directly from the water pump and distributes and pulls coolant from both of the blocks, or I should say the banks of the engine, through this entire plumbing system over here. This is our thermostat, and this is our EGR valve, our coolant temperature sensor. These go to our heater core. These go to different bypasses. We're going to pull the whole thing off in one unit. That way it'll give us more access to more of the engine. So here you can see the cam that drives the fuel pump. Looks like it's a triangle shaped, and that's right where the cam follower rides, and here is the housing that connects it to it. All right, now that the rocker assemblies are removed, you can see a little bit more of what's going on underneath here, such as our cam lobes and our lost motion assemblies. You'll see on bank one head, there are more lost motion assemblies because of the variable cylinder management system. Take a look over on this side. It has only 1, 2, 3 for it. All these other holes are open. So very similar design, but this one doesn't have cylinder deactivation on the bank 2. So that's some of the differences you can see between it. Let's keep on breaking things down. These are the knock sensors. There's 2, 1 for each bank. This can detect if detonation is starting to happen within the engine, and then the computer can adjust the fuel trims and timing to compensate for that. So here we have our timing belt set up. Right here is the hydraulic tensioner. This is self-contained, filled with hydraulic fluid and pressure to keep a constant tension on this adjustable idler pulley for the timing belt. We're going to remove this now and relieve the tension. And you can see that loosens the belt up to come off perfectly. This is the key. This is the keyway here and the matching one on the crank gear. This will hold it into place by sliding into both of these spots. Totally perfect. And that's how it locks it to the cam, or the crankshaft. Oh. So the interesting thing about cams is they're not solid. They have oil passages that feed in through these holes here and help keep them lubricated while they're turning. So as you can see, oil is draining out of this because it is not solid. I wouldn't say it's hollow, but it has plenty of orifices for oil to pass through, and these are some of them. That's a lost motion assembly. All right, so now we have the cylinder heads off. You can take a look and see the design of a piston. Normally, a piston is usually domed in the middle with valve reliefs on the side, or it's dished out a little bit more depending on the compression. But on a direct injection motor, you'll see there are these pockets into the piston that are a little bit different. So when the fuel sprays in, which it's at this angle, it hits this spot and atomizes more efficiently. Ooh. Lots of goodies in there. That looks like bearing material. So as you can see, there is a lot of bearing material in here, and I think we can be pretty sure that replacing this engine was the right choice because of how much damage there is to it. So let's go ahead and start pulling the pistons out, and we can take a look at these connecting rod bearings. All right, so let's go ahead and take a peek at this and see what's going on. I got a 12.10 here. I think that's what it is. Let's check it and see. Oh, they're hand tight. That's interesting. Seeing as you saw us pull the oil pan off and no one else has been in this engine, that means this had pretty serious failure, and I've never really seen a bearing come loose like that. Oh yeah, there's no bearing left inside of that. And the crank has been worn down pretty significantly. Bearing is completely gone to the point where the rod became loose. So I guess we can just start pulling caps off of this because, I mean, that is worn pretty good.
Literally, it's completely gone, John.
Yeah, there's no bearing at all.
Wow.
Well, I think the bearing was what we saw in the oil pan. This bearing is still intact, and the crank is still actually good in this area. Not good at all. You could see the coating's off and we're down to some of the copper. This was starting to fail, but not complete failure yet. This one looks like it's in decent condition, but it's starting to show signs of wear. And that's our one that's totally toast.
A lot of carbon buildup, huh?
Yeah, pretty normal on these engines. A lot of it has to do with cold start, driving the car hard, and low octane fuel. That'll do it to it. Okay, so we got everything broke down. The only thing we didn't pull off is our oil pump and our crank. We got pretty much straight down to where the issue was, and that was a bearing that was completely gone off the motor. The other thing, that being said, why did that happen? I don't know exactly why it happened, but the fact that only a quart of oil came out of the engine is a good indicator that either it was driven very far in between oil changes, or it probably hasn't had an oil change in quite some time. So I will go with oil starvation as being our main issue and cause for this bearing failure. So you could possibly get this crank refinished, where they mill it down, run oversized bearings, or you would replace it. All of that costs a lot of money and time and labor to take all this apart, clean it, put it back together, get it machined, measured, and work it out. So in the end, a junkyard engine with similar miles to what came out of the car was a better, cheaper solution for our customer. And that's what we always try and do, is make sure that we give them the best option that saves them time and saves them money. So that being said, this video is over. I thought it was pretty cool. My favorite thing about it is the huge bucket of bolts that I have over there. And we have all of this stuff. What we're gonna end up doing is scrapping it and throwing away what we can't scrap. That'll be it for this video today. I appreciate you guys coming and watching us. If you like it, you know, maybe you click like. If you really like it, maybe you'll subscribe. But for sure, this is stuff that we'll be doing here, so definitely check back in for everything else that we have going on. If you have any questions about this, let us know. We're here to answer in the comments. See you on the next one.